All right, welcome back, everyone. Welcome back to episode 4, right, of the Rust for the Absolute Beginner tutorial series. Yeah, and today we are talking about data types. All right, to begin with, there are two main categories of data types. First, we have Scala data types, where each represent a single value. And then we have compound data types, where you can group multiple values into a type. Yeah, so let's start with Scala data types. Yeah, and the first type we are going to touch on is the integer data type. Yeah, so think of integer types as basically a number. For example, we can say let this number equals to 5. Save that. Yeah, so you can see that VS Code has automatically inferred that this is an integer, I32, right? You can see this grayed out portion here. Yeah, so this is an integer data type. Yeah, so a number without any decimal points. And that I in the I32, that represents that this integer is signed. Yeah, so you can also do this. Let unsigned number U32, all right? Goes to, let's say, 10. Save, all right? So the U represents unsigned, yeah? So the difference between signed integer, I32, for example, 32 means 32 bits, yeah? And U32 is the sign in front. Yeah. So when you are declaring an integer that is signed, that means it can either be negative or positive. All right. Yeah. So that hence the sign in front of the number that tells you whether it's negative or positive. Yeah. So if you were to attempt to change this 10 to minus 10, for the unsigned integer, which is U32 over here, yeah, notice that now we have an error. Yeah, so you cannot apply the negative operator, yeah, to type unsigned 32, yeah, because you can't place the negative sign in an unsigned integer. Yeah, so that's the main difference between signed and unsigned integer. Yeah. Yeah, there are a few other variants for integer data types, okay, but that deserves its own video, so we shall not go too deep into that. Yeah, so moving on, let's talk about floating point types. Yeah, so we mentioned that integers are numbers without decimal points. Yeah, floating point data types have decimal points. For example, let pi equals to 3.14 and save. Yeah, so notice that this is inferred to be F64. Yeah, so floating point data type, 64 bits. Yeah, so the difference between this and maybe this, right? Let's maybe declare F32 is that this is 64-bit and this is 32-bit. Yeah. So in terms of the speed, it's about the same, but 64-bit has more precision. Yeah. And for most modern CPUs, they have the ability to handle 64 bits. Yeah. So by default, Rust will always assume that you want a 64-bit floating point data type. All right. And moving on to our third Scala data type, we have our Boolean, which is also available in almost every other language out there. So to declare a Boolean, let me just remove everything here. We can say let t or let bool equals to true. Yeah, so save that. Once again, Rust will be able to infer that it is a Boolean, hence this bool. Yeah. Of course, you can also declare it yourself. Let this bool equals to false. Same thing here. Yeah, it's the same way of declaring a Boolean. And moving on, next we have the character type. Yeah, so to declare a character in Rust, right, let's remove the Boolean statements here. Yeah, so to declare a character in Rust, you have to use single quotes. Yeah, so for example, let this character equals to say D. Yeah, you can see that Rust infers that this is a character data type. Yeah, so watch what happens if we use double quotes instead. Let this double quote, right, equals to D. Save that and notice that it is no longer a character. Yeah. So it is important that we have to use single quotes to define or to declare a character in Rust. All right, next let's talk about some compound data types. Right, first we have the tuple data type. Yeah, so to declare a tuple, basically we can say let this tuple equals to 500, maybe 2.4 and 1. Save. So right off the bat, you can see that a tuple allows you to group multiple data types together. Yeah, even though they are not the same. Yeah, so notice how we are having the first value as an integer, 32 bits, second value with a floating point, 64-bit, and the third value as an integer, 32 bits. Yeah. So tuple, I would say it is a good way of grouping together a number of values into a compound type. Yeah, into one type together. Yeah. And to get the individual values out from a tuple, yeah, so for example, if we say we want to access the second value, yeah, okay, we can declare that first, second, third equals to this tuple. And if we print this out, yeah, let's say second value is, this will be second, save, and if we print this out, yeah, notice that it says second value is 2.4. Yeah, so this is also how you can destructure a tuple and retrieve the values in it. All right, next we have the array data type. So if you have some programming experience, right, you might have heard of arrays. Yeah, so arrays in Rust is a little bit different. Yeah, so as compared to tuples, you can only have data values or values of the same data type in an array. So for example, let's say we have an array here, right? Let's say 100, 2.4, 1. Save that and notice that Rust is telling us that, hey, yeah, we are expecting integer types. Yeah, because most of the values here are in, or rather are of the integer type. So for arrays in Rust, the values in the array must be of the same data type. So if we change this to say 24, the array does not have an error anymore. Yeah. So this is also how you could declare an array. Yeah. And one of the differences between an array in Rust as compared to say that of TypeScript is that arrays in Rust are fixed. So you cannot push or pop on an array. Yeah. If you want a list of things that might or might not change, you would have to use vectors in Rust. Yeah. And that gives us its own video. Yeah. So we will touch on that in another video in this same series as well. Yeah. So arrays in a sense are more useful when you know that it is used to hold a fixed number of items and that the numbers will not change, and it is more performant as compared to vectors. Yeah, and that is because arrays are located on the stack as compared to the heap in terms of memory management. Okay, but we'll get to that in another video. Yeah, so as not to make things too complicated. Yeah. Okay, and similar to how you would access an element in an array in most other programming languages, you can say let first equals to this array 0. Yeah, and if we print this out, once again, first element in the array is first. Save, and let's print this out. Right, so notice that it says, right, all the way to the right, yeah, it says first element in the array is 100. Yeah. All right. So that's the gist of the basics of the most common data types in Rust. Okay, next, let's talk about functions in Rust.